situation happen, then we will say that this is not prefix code. Prefix code means you cannot have this happen. Okay, don't confuse, huh? What is prefix code again? Prefix code is when this case will not happen. If this happen, A is the left substring of 0, 1, then this is not a prefix code. Understand? If there is one which is the left substring of the others, that is not prefix code. Okay? So for example, I ask you this. If A is 0, B is 110, C is 10, D is 111. Do you think this is a prefix code?
OK， 这样我们俩，我不懂他们应该不懂做什么。哦，这样。
Is this a prefix code? If you know the answer, then I know just now what I say you understand already. Do you think this is a prefix code or not? Yes or no? Yes. Yes. It is a prefix code. Okay? Now, why we say that this is a prefix code? Because there is no code which is the other code left substring, right? How about the second one? 0, 0, 1, 1, 0, 1, 0, 0. Not a prefix code. Okay, so now you know which one is a prefix and which one is not a prefix code already. Then we can go to this Huffman code. Now this Huffman code is to construct, to find what are the code that we can have when we want to do it using the prefix code. Meaning that all the code that we found using for this Huffman code will be prefix code. Now we have the method for this one. Follow the example here. I will explain to you the steps, how to find the code for Huffman code. Now, normally they will have the probabilities given for each of the letters, meaning that which letter will happen the most. So in this case, if you see this B 0.15, 0.3, so the highest will be C. Then what we want to do is we will try to arrange the probability in descending order first. Take the highest one, put it at the first one. So this question is find a prefix-free binary code, meaning that we want to find a code, a set of code. So we will arrange it like this. 0.3, first one, the highest, followed by 0.29, and then 0.16, 0.15, and 0.1. This is the descending order. Now, after you arrange in descending order, we will total up the two smallest probability. This is 0.25. So after we get this, we need to rearrange again to get the descending order. So 0.25 will be here. Okay, 29, 25, 0.16. Repeat the same thing until we get all total to 1. So this one, you total up, you will get 0.41. If you rearrange, you will have 0.41 as the first one, 0.3 and 0.29. Okay, then we have this one, 0.59. It will become the first one now, and 0.41. The total you get, the last step must be 1. If after you do all this, the last step you cannot get 1, that means you do it wrong somewhere else. So you need to redo. Okay, because total probability must be equal to 1. this is what you do. You can write it under this picture. Arrange the probability in descending order and match the two lowest values. Then, after that, we will draw the binary tree. So you can write the answer here. I want to refer to the probability, so I write here. Okay, you can write it on the page below. Now, when we want to construct the binary tree, we will start with the probability 1. Then split down to what we have here. 0.59 and 0.41. We follow the sequence, the bigger probability put at the left, the smaller probability put at the right. Every time go down, do the same. As long as it is larger, put at the left, smaller, put at the right. Then after that, you have 0.3 and 0.29 under 0.59. This is 0.3 and this is 0.29. Under 0.41, 0.25 and 0.16. And then under 0.25, 0.15 and 0.1. Okay? So you get the binary tree from the total of the probability that you have done just now. Done? Now, after you have done this, we can label the letter symbol here. A, the probability is 0.1. So under 0.1, we will label it as A. B, 0.15. C, 0.3. D, 0.16. And E, 0.29. So we will label, follow the question here, the probability given in the question. Okay? A is 0.1, so you put under 0.1 A. Then, at the side here, all the edges, we will put the 0 and 1 because we want to construct the code. At the left, always put 0. At the right, always put 1. So we will have this 0, 1, 0, 1 for us to find the code later on. Okay, put the 0, 1, 0, 1. Then we can write the code for A to E now. So the code for A, there is a table in your notes, right? So you just fill in the table lah. So the code A will be, start from here, go until A. So you just read 1, 0, 1. Okay, so the code A is 1, 0, 1. B, start from the top here to go to B, you have 1, 0, 0. C is 0, 0. D will be 1, 1. And E is 0, 1. Okay, so start from the top here until the alphabet that you want to find, you can get the code. Understand? Done? Okay, so here you get the code already, right? So what else they want you to do? The code length. So just now you already get this. This is the length here, 3. This one also 3. This is 2, 2, 2. The length is just the number of bits for the code. Okay, so when we want to find one more, see the question here? Expected code word length. See, you already find the binary prefix-free binary code, which is this. This is the binary code. Okay, so in order to get the code, you must do this step and the 3. These 2 to get the code. And after that, only you find the expected code word length. So to get the length, actually these are all the length for each code, but expected means the average length. What is the average length for each alphabet? So how to calculate the average? We will use this one, this formula. The length multiplied with the probability and then total up everything. Okay, the summation of the length multiplied with the probability. So this one, the length is 3. Then you just use like this. Expected code length, LC, equal to, this one is the formula. Then I just write, the length is 3 multiply, what is the probability for A? 0.1 plus B, length 3, probability 0.15 plus C, length 2, probability 0.3 plus D, length 2, probability 0.16 and E also length 2, probability 0.29. So we need to total up everything. What do you get? Yes? You calculate not? 2.25. Yes. So the unit we can use the bits per symbol. Per symbol means for one symbol here, A to E, right? It can be, the length can be 2.25, the average. Because some of them they have 3, some of them they have 2, isn't it? So if you take the average of all these, you will get each of them, the bit is 2.25 bits. That is what we calculate for the expected code length. Okay? Now, if we, after you have calculated this expected code length, isn't it? We can actually follow the theorem from Shannon saying that there is a minimum value for this expected code length, meaning that there cannot be lower than one particular value. So if you follow the Shannon's theorem, we need to know what is the lowest length of the code. that is possible. So to calculate this, we will use this entropy. Okay? Now, if you follow this theorem, the code length cannot be lower than this formula. Meaning that you need to calculate using the probability given of each alphabet, multiply the log of the probability. So the log of the probability will be in base 2. Log base 2. Okay? Now, I think some of your calculator, if you cannot change the base to base 2, then you know how to do that? You can change the base to base 10. Okay? Then you just divide the log probability xi divide by log, this one is 2, right? Then you put this as your base 10. Okay? Change to base 10. Just take the log, the probability base 10, divide by log 2 base 10. Understand? This is if your calculator don't have a function, change to the base 2. If you have, straight away press no problem. So of course in front you need to multiply multiply with the probability xi. And then take the summation. Why we have a negative in front is because normally the probability 0 point something will be a negative value. So if you total up, the total here will be negative. That's why there is another negative in front. Okay? So that the final answer will be positive. So we try to calculate. You can change this to either log base 10 or log base e. Because normally the calculator will have these two bases. One is 10, one is e, isn't it? So it is up to you. You will get the same answer also if you change to both of these, base 10 or base e, which is log. Base e is log. Okay, now we look at the example. So we use the same example just now and find this one. Try to familiarize with this formula. See, here they didn't write log with what base. No base means it is base 10. So we already convert the base 2 to base 10 because this is divided by log 2. So you use just now that one. The probability 0 point what? This probability. 1, 1, 5, 3, 1, 6, and 2, 9. Use this to find the entropy. You can do like this. The entropy is Hx. Hx. So you calculate the probability 0.1 times just now that one, log. I use straight away base 2 plus 0.15 log 0.15 plus 0.3 log 0.3 and 0.16 log base 2 0.16 plus 0.29 log base 2 0.29. Okay? So you total up everything here, and in front you need to put a negative. You try to calculate and see.